So starting today, we're going to be on 5.3, identifying proportional relationships. So today we're going to be talking about proportions. A proportion is two ratios that are set equal to each other. You can see 1 to 2 equals 3 to 6, or in our case it looks like 1/2 equals 3/6. We're going to also be talking about cross products today, which I'm hoping is going to be a review to you where you are multiplying the number that's across from it. Okay, so if you look over here, we've got 3 is to 4 as x is to 10. If you would take your red pen and I want you to circle 3 and 10 because those are across from each other. Then basically what you can see over here, that means you're going to write 3 times 10. You're multiplying them together. The other ones you're going to multiply together, we'll circle here also, 4 and x. And you can see over here that equals 4 times x. So this is how cross products works, and we're going to do a few problems using cross products. This asks us to tell whether or not the ratios form a proportion. Now, if they equal each other, then they will form a proportion. So let's look at the first one. 6 to 4. How would I write that as a fraction? 6 over 4. And we're trying to see if they equal each other, so I'm going to put equals, and then how would I write 8 to 12? 8 over 12. Now if you would, use your red pen and we're going to circle them diagonally. 6 and 12, and then 4 and 8. If you remember in previous chapters, we've tried to keep our equal signs lined up. So I'm going to drop down the equal sign directly underneath. The first thing I'm going to focus on is this right here, that number on the top left multiplied by the one on the bottom right, 6 times 12. So let's just write 6 times 12. Then I'm going to multiply 4 times the number 8. 4 times 8, because it's whichever one is across from it. Now once again, let's drop down our equal sign. Let's focus on the left side. Class, what is 6 times 12? 72. And now let's look on the right side. What's 4 times 8? 32. Guys, does 32 equal 72? No, it does not. So take your red pen. I want you to put a little slash through it. What that says is 72 does not equal 32. So in question number 1, it says, tell whether the ratios form a proportion. Do they? Yes or no? No, they do not because they're not equal. So you're going to go ahead and box in the word no. Problem B says 10 to 40 and 2.5 to 10. Just the girls. How do I write 10 to 40 as a fraction? 10 over 40. And remember, we're trying to see if they're proportionate, so I'm going to put an equal sign there. And boys, what is that? It equals 2.5 over 10. All right, so once again, let's circle the cross products and drop down your equal sign. On the left side, we're going to write 10 times 10. And on the right side, I'm going to say 40 times 2.5. Drop down your equal sign. I want you guys to plug those into your calculators and see what you get. All right, what's 10 times 10? 100. And what's 40 times 2.5? 100. Does 100 equal 100? Yes. So the answer would also be yes, they do form a proportion. If you look at the next one, it's a little different because I have fractions there, but we know how to divide fractions also. So it's going to be 1/2 divided by 1/4 is equivalent or equal to, what will the other one be for 8 to 4? 8 over 4. Once again, we're going to use our cross product. So I've got 1/2 is diagonal from the 4. What is 1/4 diagonal from? The 8. Drop down your equal sign. On the left side, I'm going to have 1/2 times what number? 4. Very good. And I can put that over a 1 if I want. On the right side, I'm going to have 1/4 times 8. You can also put over 1. Talila, is there anything that I can cross reduce on the left side? Okay, 2 and 4, what did they become? Very good. And on the right side, Einar, can I cross reduce anything there? Yes. Which ones? 4 and 8. And what did they become? 1 and 2. Very good. When I multiply that out, what do I get, guys? 2 over 1, which is just 2, equals, and what about the right side? 2 over 1, which also equals 2. Are those equivalent?
Yes.
Yes, which means they do form a proportion. All right, so even when you have fractions, you can still do it the same exact way with your cross products. Let me have you guys try to do problem D on your own. All right, who would like to help me with what you got? Noah.
You write down 6 over 9 equals 12 over 18.
Very good.
You circle the diagonal. And you do 6 times, you drop an equal sign for 6 times 18 equals 9 times 12. And you multiply that out and you go to 1.
You are correct. So is the answer yes or no? It is yes. They are a proportion because they do equal each other. How many of you guys would say you got that same exact thing? Excellent. All right, let me have next one. Matthew, what should I do? All right, and does 10 equal 12? No, it does not. So guys, take your red pen and put a little line through it saying 10 does not equal 12, which means no, they are not a proportion because they are not equivalent to each other. All right, section number 2 says to tell whether the quantities are proportional by finding the value of the ratio. So let's remind ourselves, we did this in 5.1 and 2. If I'm going from the top down to the bottom, do I multiply or divide? Divide, and then just as a reminder, if I'm going from the bottom to the top, then I have to multiply. All right, so we are finding 4 different scenarios here. So if you would, just label it 1, 2, 3, and 4 on top of your table. All right, so looking at this very first one here, if you guys would just put a little 1, I am trying to get from 1/2 down to 3, and I'm trying to figure out the value of my ratio. From going top to bottom, do I divide or multiply? Divide. So we're going to be going 1/2 divided by 3. Remember the way that we kind of talked this through last time? That means 1/2 divided by 3 over what number? Over 1. Brayden, what should I do next?
KFC.
Very good. We're going to do KFC. So we'll keep the first one, flip the second one, and then change the operation. Isaac, when you multiply that out, what do you get for the value of your ratio?
You get 6.
Okay, remember you're going to multiply the numerators first and then the denominators. So what would you get?
You would get 1 over 6.
1 over 6 is correct, okay? So 1/6 is the value. I want you guys to put the value of the ratio up at the top. Now, we're not going to put that all the way across because we are trying to discover, is the value of the ratio the same? Notice it already told me everything for x. It told me everything for y. So let's move on to number 2 and see if we can find the value of that ratio. We're going to take the top number and divide it by the bottom number. What would you get when you do that? 1 over 6. Can I reduce that or anything? No. So that is, once again, this is great. The value of the ratio appears to be the same so far. Let's go to the third one. What should I do with that third one, Ava? Okay, so we're going to take the top number and divide it by the bottom number. Okay, writing that off to the side, that means 3/2 divided by 9 over 1. Ava, keep going. Okay, we're going to do KFC. Keep the first one, flip the second one, and then change the operation. All right, Angeline, is there anything that I can cross-reduce? The 3 and the 9, very good. They become a 1 and a 3. And let's multiply that out. Jalen, when you multiply that, what do you get? 1/6. Once again, does it look so far that it's proportional?
Yes.
So far it does. Let's put that 1/6 up at the top. And there's only one left. How would I do that, Hayden? Very good. We're going to do a 2 over 12. Hayden, can that be reduced at all? Yep. What number goes into a 2 that also goes into a 12? A 2. So if I divide by 2 on top and on bottom, what do I get, Hayden? 1/6. So guys, looking at that, does it appear as though this is proportional?
Yes.
Yes, it does. So somewhere there, just go ahead and find some room. Yes, that is proportional because the value of the ratio was the same all the way across. Let's look at the next one. Same kind of idea. We're trying to figure out if these are proportional or not by finding the value of our ratio. So let's first off go ahead and label. We've got 1, 2, 3, and 4 different sections that we're going to be trying to find the value of their ratio. Let's start with the very first one. What should I write, Amira? 2 divided by 4, 2 over 4. Can that be reduced at all? What would it be? 1/2. All right, so the first value of my ratio is 1/2. We're going to put that up into our table. Next one, Huang, number 2. What should I write?
4 divided by 2.
Very good. We're going to do 4 divided by 2. And what is 4 divided by 2?
1.
Very good. It would be 2 over 1. And if I simplified that, I would get plain old 2. Does it look like it is equivalent so far? No, it doesn't. Let's keep going. All right, let's go on to number 3. Hope, how do I do number 3?
6 divided by 1.
6 divided by 1. If you simplify that, Hope, what do you get? 6. Another value of the ratio that looks different. Let's put that up in the table. And the final one. Trenton, help me with it. How do I do that? 8 divided by 1/2. Okay, so we know how to do this. That means 8 divided by 1/2. What method do I have to use, guys? KFC. Keep the first one, flip the second one, and change that operation. Gavin, when you multiply that out, what do you get? 16 over 1, which is just plain old 16. All right, what do you think, guys? Is this proportional? No, because the value of the ratio is different all the way across the table. It is not proportional because it was not equivalent or it did not equal each other. All right, for this modeling real life problem, it tells us that you swim 20 laps in 16 minutes. Have any of you guys ever competitively swam before? All right, back in high school, I used to be on the swim team, okay? So this is realistic, all right? 20 laps in 16 minutes. Of the total laps that you swam, you completed your first 4 laps in 2.4 minutes. Are the rates proportional? Remind me again, what does proportional mean?
Equal.
Equal, okay? Are those rates equal to each other? So let's start off with the first one. We want to make sure that we do have units attached. How many minutes did it take us to do 20 laps?
16.
All right, so 20 laps to 16 minutes. We're going to write it once again like a fraction. We're trying to see if it's proportional, so we're going to put an equal sign. Now, here's one thing I want you to really focus on. If I have laps at the top, on the right side, I need to make it equivalent for laps should also be on the top. What do you think I'm going to put on the bottom? 2.4 minutes. Okay, once again, you want to see if I have minutes on the bottom on the left side, I also have to have minutes on the bottom on the right side. So now let's do this like we've been doing today, cross products. What's going to be across from 20 laps? 2.4. So circle that. And then what's across from 16? 4. Let's drop down the equal sign. On the right side, I'm going to write 20 times what? 2.4. Talila, what should I put on the right side? 16 times 4 is correct. Drop down your equal sign one more time. On the left side, Einar, what's 20 times 2.4? 48. Angeline, on the right side, what's 16 times 4? 64. Jalen, what do you think? Do those equal each other? No, I'm going to take my red pen and draw that little does not equal. So, are these proportional, yes or no? No, they are not, because they did not equal each other. Now, let's think if this makes sense. If you have to go 20 laps total, do you think your last 4 laps would still be the same speed as your first 4 laps? No, why not? You're out of breath, you're very tired. Your time is probably starting to slow down. So it makes sense that no, these rates are not going to be proportional. Let's do another problem together. You do 120 sit-ups in 3 minutes. Your friend does 148 sit-ups in 3.5 minutes. Do these rates form a proportion? All right, so first things first, we're going to start writing a proportion. 120 sit-ups in how many minutes, guys?
3 minutes.
3 minutes. What do you think I need to do now?
Equal sign.
Good job. We're trying to see if they're proportional, so I'm going to put an equal sign. Your friend does how many? 148 sit-ups in 3.5 minutes. So here's the deal, guys. Once again, look, sit-ups are on top on the left side, which means sit-ups have to be on top on the right side. Same with the minutes. So you're doing sit-ups per minute on both sides. Now, what do I have to do? Cross multiply. We're using our cross product, so we multiply the things that are across from each other. Drop down the equal sign. On the left side, I'm going to write 120 times 3.5. Excellent. On the right side, I'm going to write. Very good. Now, it does not matter which order you put it in. You could say 3 times 148, or you could say 148 times 3. You're going to get the same answer no matter what. Brayden, on the left side, what's 120 times 3.5? 420 is correct. And on the right side, Gavin, what's 3 times 148? All right, 444. What do you think, guys? Are those equivalent? No, so I'm going to put my little slash through it that says it does not equal. So do they form a proportion? No. No, they do not. So tonight you have 10 problems for your homework over 5.3. If you haven't yet, please write this down, and then you guys may get started on your homework for tonight.